Hello, thanks for stopping by. Doug over at Moslack's been playing around with his IM5284 uh, FET multimeter, and he said that he wanted to take and convert it over to running on AC power instead of the batteries. So he took and ordered a converter from China to take and put out the plus and minus 9 volts that he needs. So I thought we'd take a look and see whether we can't take and make our own. Now, the first thing we need to do, he's using a 6-volt wall wart, so we have to take and bring the 6 volts up to 9 volts. Now, to do that, we're going to be using a chip called an MC34063A. It's a 1.5 amp step up, step down, or inverting switching regulator. And I played around with these a lot. They're a lot of fun to play with. There's 3 different circuits you can take and make depending on what you're doing. As you can see in this picture here, there's 3 different configurations you can take and set it up for. You can take and set it up as a boost converter, switch the inductors around and stuff, set it up as a buck converter, or you can actually take and set it up to be an inverting converter, or in order to take positive voltage in and put negative voltage out. We're going to be using it as a boost converter, and this is a circuit I came up with. It takes the 6 volts in, puts out 9 volts at around 100 milliamps. Now when you're using this chip in the boost converter configuration like this, there are 6 components that you have to take and compute. Number 1 there, the RSC, that takes in its shunt resistor to take and measure how much current the circuit is pulling. If it tries to pull too much current, it'll take and shut down the oscillator. Number 2, the inductor, you have to take and figure out how many microhenry you need and also what current it has to be able to carry. Number 3 determines the oscillator frequency. This particular circuit here I have running at 80 kilohertz. Number 4, the output capacitor there determines what your ripple voltage is going to be. And 5 and 6 is a voltage divider that you take and compute, so that at 9 volts, this puts 1.25 volts on pin 5, which is compared with the internal voltage regulator, and that's what regulates the voltage. Now to take and compute this, there's rather simple formulas that you can see here. If you want to take and figure it out and do it longhand by yourself. But I find it much easier to take and use, there's converter programs on the internet, and also this is an Excel spreadsheet that I use. And this is what I use to take and figure out this particular thing here. Voltage in is 6 volts, output is 9 volts. Minimum voltage I have is 5.8. You have to take and put a minimum. Output current 0.1 amp. Frequency 80 kilohertz. And I said that R1 was going to be a 10K resistor. And then if you look in the column under step up, if you go down, it says I need at least a 195 picofarad capacitor. Well, the nearest one to that is the 220. RSC is 0.9. I put a half ohm resistor in there that'll take and let it draw a little bit more current. The I peak there of 0.325 amp means that the inductor has to be able to take at least carry that much current, while I use a half amp inductor. Output capacitor 338 microfarad. I used the 330. Okay, now that we have our 9 volts, let's worry about the negative 9 volts that we need. For that, we're going to be using an ICL7660s, which is a negative voltage converter. It's really simple to use. As you can see from this diagram here, you put a 10 microfarad capacitor from 2 to 4, ground pin 3, feed whatever voltage you're using. Like in this case, we'll be feeding our 9 volts into pin 8. You get minus 9 volts out of pin 5. Just about the easiest thing in the world. Nice to make if you're playing with op amps on a breadboard or something like that. You can take and throw one of those on and feed the 5 volts into it and get minus 5 volts. So you have your plus and minus 5 volts for running your op amp. When everything's all assembled and put together on a piece of perf board, looks like this. On the left we have our boost converter. On the right we have our negative voltage chip. Now let's take it out to the bench, hook it up to voltmeter and power supply, and see whether it works. Okay, let's see how we did here. I have my power supply here. BK multimeter. Check our input voltage. We have 6.04 volts going in. Our output. Positive output, 8.94 volts. Negative output, minus 8.94 volts. That sure looks close enough for me. Now let's see whether it'll actually power anything. Okay, this is my IB5281 meter, which is the same series as Doug's. I have our power supply taken, snapped in place of the batteries. Let's turn it on. We should see the needle swing up. And it does. Now, take and adjust it up for maximum. Hook a resistor across it. Dip is right around 100 ohms, right where it belongs. So it looks to me like the power supply works fine. Well, that just about wraps this one up. One reason I like playing around with these particular components a lot is because they're dirt cheap. If you look here, the MC34063 is 10 for $1.42. And the 7660 is the same thing. Basically, you might as well say they're 15 cents a piece. So if you accidentally take and burn one up playing around with it, fine. And just download the data sheets on them and follow the instructions in the data sheet, the diagrams they have there. Most of if you take and you buy any of the modules that the Chinese make up using these chips or whatever, that's all they do. They just take and follow the manufacturer's suggested diagram, and they work fine. And play around with them. What do you got to lose? You make up your own power supplies. So I hope this gives you some idea of how easy it is to take and make things rather than just take and buy things. Thanks for stopping by.